Australian border, and the larvae come along on the currents, and they come into all the inlets, and as I understand it, they seek out seagrass and they grow for a year or so in the seagrass. So they need that as a habitat.
Swans spread themselves out over the seagrass beds, and they actually, I believe they actively deplete them, so that by the end of March and April, I think in some areas the swans have actually just about worked the whole seagrass beds over. And this means that their numbers are actually quite closely related to the area of seagrass. But it also highlights just how important their role is in getting the nutrient cycling of Western Port moving along, because Western Port is what we call a detritus-based system. It depends on the seagrass fixing the energy and through its growth, and then it's dying and it's being broken off by swans. It forms this detritus, this material that most of the animals in the mud in the ecosystem survive on. So it's kind of the powerhouse of the thing. It's the trees of the forest, if you like, in other habitats. And swans have this great role in they break off the seagrass, they eat some of it, but they cause a lot of it to drift away, and that rots down and becomes this very important food for all the invertebrates in the mud.
In Western Port, the seagrasses grow using sunlight. There's seaweeds that live there, there's little planktonic animals, there's all sorts of filter feeders, so the sponges and the corals and the sea squirts are all sucking animal and plant remains out of the water. They're sort of filtering it constantly, and then there's little crabs and sea spiders and snails that feed on those, and then there's fish that feed on those, and then there's penguins and seals and all sorts of other animals coming up the food chain. Sharks move into the bay. They even see killer whales at Seal Rocks off Phillip Island. So everything is covered in that one area.
Now it's a very different story. The fishery and catches have gone right down, and the seagrasses have largely disappeared. They're coming back in spots here and there, but as long as there's continued input of sediment, it's going to be very hard for them to recover.
What we do know is that climate change is forcing nature, forcing ecosystems places they've never ever been before, and we don't understand them now, let alone where we're pushing them to. So, I mean, we're really changing the climate and changing those things that support us as a species and our economy in parallel. We're forcing them to our peril.
Typically what we're finding is that by about 2070, what was typically a 1 in 100 year event under current climate conditions tends to suddenly become a less than 1 in 10 year event. So now that's not to say we're going to be getting the storms much more frequently, it's just that a much weaker storm surge event has greater impact because the sea levels are much higher. One of the important things people have to remember with sea level rise is that, particularly on a sandy shoreline, a soft shoreline, a vertical sea level rise of say 1 metre can lead to 50 to 100 times the shoreline recession, and that's because the shoreline is no longer in equilibrium with that particular sea level, so it erodes, and so you get wave attack higher up the beach, it takes sand offshore, and so the erosion will be much greater than the vertical sea level rise.
So with the sea level rising and the shoreline completely unprotected because the mangroves were removed, we need to get planting.
We believe that the only way to stop that effectively happening is to re-establish the mangrove forests that used to effectively cover most of the coastline of Western Port. Many of those forests of mangroves have disappeared for all sorts of reasons and causes, including even in the 19th century they extensively harvested them and burnt the timber to give a high potash ash which was used for making shaving soap, of all things. You can go to Stony Point now and see a mangrove forest which is 200 metres wide, and that's what they used to be over most of the bay.
Mangroves are an amazing tree. They're amazing on a lot of levels. To start with, they're living in seawater, which would kill most trees or shrubs, so they're very good at coping with salt. They live in mud that, not far below the surface, it runs out of oxygen because it's so dense the oxygen can't penetrate. And so they grow these special roots that are like air roots that come up as fingers out of the mud.
They're like that asparagus that you
Yeah,
see.
it looks like asparagus underwater, and they're all air-breathing roots that allow them to get the gases they need to breathe and to photosynthesize up and down to their roots, because otherwise the mud, they just die straight away. And those roots are fantastic because they trap sediment that's in the water, it falls down amongst the roots and it helps bind together the mud. So when the current's screaming past, the mangroves are actually stopping all that mud being lifted up into the water again, where it can cause all this sort of dirty water and problems for other plants. But they do other incredible things. The way they cope with salt is by concentrating all the salt into 1 or 2 leaves at a time, and you get this bright yellow leaf that's almost pure salt, and then it just breaks the leaf off and drops it on the mud, so that the rest of the plant's healthy while this one leaf is the little salt factory for them. The roots and all the growth of the plant are fantastic for fish to live in. All sorts of animals live on the roots and the mangroves. All sorts of birds nest and roost in the mangroves. There's little stalk-eyed crabs running around the roots of the mangroves at low tide. They just play a really critical role, and we tend to clear mangroves out to do coastal developments, and they're what's actually keeping those areas sort of pristine and healthy.
It's the nursery grounds for lots of fish, flounder and flathead, and the 3 fish that penguins eat come from the mangrove. So the fish that the penguin eats right out there, the penguin doesn't come here to get them, they go out to the penguins.
In the midst of all the bad news about the environment, here's some very good news. These students here, who with their teachers are from the Bass Valley Primary School, are working with the estimable Dr. Mangrove on replanting programs.
See if we can get it established, and then we might be able to take healthy bits from here, spread it around to other places.
They're replanting in some areas seagrass. They're planting seagrass here.
This is a patch that's going well. Now that was a 10 centimetre core, and you can see it's quite luxurious now, and these it's growing these stolons. When a storm comes, these will break off and they'll settle somewhere else and grow. So this sort of thing we want to promote in different places.
In other areas they're planting mangroves. They're measuring the progress of these plantings. They're noting all the cores that they're planting. They're very often propagating and growing the little plants inside the school in little containers, and then they put them in the sea and they plant them. They plant them in all weathers, and then they go home and their mothers do the washing.
Some of the land care groups working in the catchment of Western Port have got a very nice slogan. It's called Slow the Flow. They accept the water has to flow somehow into Western Port. But the more slowly it flows, the more it can sink into the soil, it can be purified as it goes.
We're trying to make the levee banks a bit flatter so the river can start to use up its energy, or the drain can use up its energy by meandering in the bottom instead of just rushing through with great power.
You mean that will slow it down?
Yep, it'll use its energy, moving backwards and forwards and hitting against the big rocks that we've put in there, and instead of gouging deeper and causing slumping of the levees. So we've built a really big sediment trap at the start of the Yallock outfall at Cora Lynn. It's a big high flow floodway which takes off the Bunyip main drain. So a massive sediment trap has been put in there to capture.
And what's the theory there? What's it supposed to do?
It'll capture the bed load.
Right.
We're hoping, all the sand and gravel, and it's doing a fairly good job as well.
Every little bit would help, because the water would flow more slowly, and that would give the sediment time to settle out on the land itself and not be transported into the bay, waters of the bay. So the water trickling into the bay would then be clean, clear water and not turbid water.
It's only very slowly responding. We're just sort of seeing things now in coastal erosion, changes to the tidal channels, changes to the seagrass, a whole lot of stuff that we didn't understand when we made those decisions to drain it. And understanding, of course, nowadays the importance of access to fresh water is another issue.
How many trees have you planted as a matter of interest?
Over the 20 years of land care in this region, it's in excess of 1 million plants just in the Bass catchment. There's probably 250,000 to 500,000 plants been established on Phillip Island, and probably something similar on French Island. There's still a long way to go, and like I said earlier, 7% currently native vegetation cover, and we're aiming for a minimum of 30% over time. And at the rate we're going at the moment, it's going to take a really long time, so at some stage we're going to have to amp up the level of activity and resources and support made available to people on the land to increase their impact on the landscape.
I think you'd get very rapid recovery of the animals and plants in the system if there was more planting to sort of stabilise those beds of mud that just keep getting lifted up every time the currents go by. If you can look at things like nutrient runoff and superphosphating on farms in the area, if there can be just more sensitivity to moving over seagrass beds with boats and propellers and anchors, I think you could find that all those things would be recolonised. Marine animals are actually surprisingly good at, when they're given a break again, booming back into that environment, because there's relatives of them out in open ocean along the outside coast of Victoria, and so they can migrate back into the system relatively easy. Their young are usually little floating babies in the plankton, and as long as there's somewhere suitable to settle down, they'll settle and spread and recover very well.
One of my dreams has always been to have as much wetland restored in the former Kooyup swamp as it's possible to do. So without getting onto anybody's farmland, we can say, well, let's put the roadside verges back under wetland. Let's put that bit of land that no one's doing anything with back into wetland. Let's try to buy as much as we can of the top mile or 3 or 4 kilometres of land around the top end of the bay, and let it go back to being swamp, a little tiny ribbon of swamp.
The problems are quite easily identifiable. They're not going to be easy to fix, but we have to do it. We caused them. It's up to us now.